Welcome, my superstars, to this definitive ICSE Board Masterclass explainer. Look, I know this chapter, mole concept and stoichiometry, is that one topic that gives everybody sleepless nights, right? It is totally normal to see it as the biggest hurdle in Class 10 chemistry. But listen to me, I've been an ICSE board examiner for 25 years. I know exactly how this works, and I promise you, by the time we finish this explainer, that fear is going to completely vanish. We're going to totally eliminate your biggest chemistry headache and literally turn you into stoichiometry heroes. So let's just dive right in.
Here is our ultimate bootcamp syllabus for today. We are looking at exam weightage, the core concepts, board question archetypes, and finally, my personal examiner travel alert. All right, Section 1, exam weightage and exactly where you need to focus your energy.
Mark my words on this one. This chapter holds a massive weightage of 10 to 12 marks on your final board paper. That's roughly 8 to 10% of your entire chemistry exam. So, if you're aiming for a perfect 100, this chapter is absolutely unskippable. You can't just gloss over it hoping for the best, you really have to master it. Moving right along to Section 2, the core concepts. Let's start with Gay-Lussac's Law of Combining Volumes. Now, here is the exact board-approved legal definition that we examiners are looking for. You need to memorize this word for word. When gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the gaseous product, provided that all the volumes are measured at the same temperature and pressure. Now, pause for a second. What's absolutely critical here is what I call the liquid water trap. This law only applies to gases. So if a reaction produces water and it's at room temperature, meaning, it's a liquid, its volume is treated as 0 in these calculations. Do not, under any circumstances, count liquid water in your volume ratios.
Next up, we have Avogadro's law. And honestly, this brilliantly illustrates the relationship between volume and molecules. It simply states, equal volumes of all gases under the same conditions of temperature and pressure contain equal number of molecules. It's really that simple. If I have, say, 50 milliliters of hydrogen and 50 milliliters of chlorine under the exact same conditions, they have the exact same number of molecules. Identical volume literally means identical molecules.
Okay, let's disarm the intimidation factor of the mole. I see students panic all the time when they hear mole concept. But think about it. A dozen simply means 12 items, right? A dozen eggs is just 12 eggs. Well, a mole is the exact same concept. It's just a way bigger number. 1 mole simply means 6.022 times 10 to the power of 23 particles. That's Avogadro's number. It's just a counting unit, nothing more. Seriously, don't let the word scare you.
Moving on to vapor density. Guys, this is the golden formula that will absolutely save you in Section A of your paper. Molecular mass equals 2 multiplied by vapor density. So if the board gives you a vapor density of 14, your molecular mass is just 28. Simple as that. If you ever need to find the relative molecular mass of a gas mixture, just find the vapor density and multiply it by 2. This is easily the easiest 2 marks you can secure.
Now let's talk about Section B. Here is the mandatory 5-column table template for calculating empirical formulas. As an examiner, if I open your paper and see this exact table, you are instantly on track for full marks. Your columns must be element, percentage composition, atomic mass, atomic ratio, and simplest whole number ratio. It's a straightforward process. You divide the percentage by the atomic mass to get your atomic ratio. Then you divide all those answers by the smallest atomic ratio you got, which gives you your simple ratio.
But here is where even the smart students stumble. The strict decimal rounding rule. If your simple ratio ends up being something like 1.5, you absolutely cannot just round it up to 2. That is a fatal error on a board exam. Instead, you must multiply the entire ratio by 2 to get a whole number, which would make it 3. If it ends in 0.33, you've got to multiply by 3. You must establish a proper whole number ratio for your empirical formula without distorting the math.
All right, for mass, volume, and mole calculations, I'm handing you my foolproof 3-step stoichiometry method playbook. Step 1, write and balance the chemical equation. Guys, no balance, no marks, period. Step 2, establish the mole-to-mole ratio between your given substance and your target substance. And step 3, convert those moles to the required unit. You'll use gram molecular weight if you need mass, or 22.4 liters at standard temperature and pressure if you need volume. Stick to these 3 steps and you literally will never get lost.
Let's jump into Section 3, Board Question Archetypes.
It is time to enter the battlefield phase. Archetype 1 is your classic gaseous volume or Gay-Lussac question. This typically pops up in Section A to test your understanding of gas mixture compositions. It'll look something like this. What volume of oxygen is required to burn 224 cubic centimeters of methane? Okay, let's walk through the exact examiner-approved steps for this. First, we need the balanced equation. CH4 plus 2O2 yields CO2 plus 2H2O. Just look at the coefficients. 1 volume of methane requires 2 volumes of oxygen. It's a straight 1:2 ratio. So if we have 224 cubic centimeters of methane, we just multiply that by 2. The answer is 448 cubic centimeters of oxygen. Rely directly on those balanced volume coefficients, and honestly, it's effortless.
Now for archetype 2. This is the classic 4-mark structured empirical and molecular formula question you'll see in Section B. An organic compound has 47.4% carbon, 10.5% hydrogen, and the rest oxygen. The relative molecular mass is 76. Find its empirical and molecular formula.
Let's guide you through the math here. Step 1, find that missing oxygen percentage by subtracting the given percentages from 100. That gives us 42.1%. Step 2, use that 5-column table we just talked about to find the empirical formula, which comes out to C2H5O. Now here is the critical step. You have to divide the given relative molecular mass of 76 by the empirical mass, which is 45, to find your multiplier, N. So 76 divided by 45 gives you roughly 1.68, which we then round to the nearest whole number, 2. Finally, just multiply the empirical formula by 2 to get the full molecular formula, C4H10O2.
Archetype 3 is your standard mass stoichiometry calculation problem. Calculate the mass of water formed when 4 grams of hydrogen reacts completely with oxygen. This perfectly demonstrates our 3-step method in action. Here's the step-by-step breakdown that will get you full marks. Step 1. Balance the equation. 2H2 plus O2 yields 2H2O. Step 2. Establish the ratio. 4 grams of hydrogen is exactly 2 moles. And our balanced equation shows a 2:2 ratio between hydrogen and water. This means 2 moles of hydrogen produces exactly 2 moles of water. Step 3. Convert those moles. 2 moles of water multiplied by 18 grams per mole equals 36 grams. Proving once again that if you have a balanced equation, that mole-to-mole ratio makes the final conversion an absolute breeze. Finally, we reach Section 4, the board examiner's trap alert. We are now officially navigating the minefield. As an examiner, I demand that my superstars never make these silly mistakes. First, the unbalanced equation. If you start stoichiometry without checking if the equation is balanced, you lose all marks instantly. No exceptions. Second, confusing atoms versus molecules. Remember, the oxygen gas you breathe is O2. It's a molecule, not just a single O atom. Third, and this one really breaks my heart every time I see it, dividing by the atomic number instead of the atomic weight when finding the empirical formula. Always use the weight. Fourth, missing the step where you divide all obtained mole values by the smallest mole value to find the simplest ratio. And finally, exactly as we discussed earlier, counting liquid water in Gay-Lussac's gaseous volumes. Avoid these 5 fatal traps, and you are golden. So, I want to leave you with this final thought. Are you ready to secure your 100% in chemistry? Think about it. You now have the veteran strategies, you know the exact board archetypes they're going to throw at you, and you know exactly how to avoid the examiner traps. The mole concept is no longer your enemy, it's your ultimate tool for success. Stay focused, practice these steps, and go ace that ICSE exam.